What's up guys, this is the first episode of Python Libraries Explained. This episode is for NumPy. What we are going to do is first of all show the NumPy documentation, then we move to a NumPy installation using virtual environment, and then show two simple examples to move to hand-on practice. So here we have the documentation of NumPy. It's very recommended every time that we use a Python library, check its documentation, because here we have all the fundamentals, all the tutorials, all the information that we are going to need for our applications. So I'm going to leave the documentation link in the description, but let's move to the installation part. As I said, we are going to use a virtual environment to prevent of installing every time a new Python library locally on our computer. To create a virtual environment, here we need to execute this Python command, and then wait until this directory is created and the process finished. So now we need to activate our virtual environment using this line here, calling the virtual environment directory inside the scripts and activate. We press intro and here appears, as we are inside our virtual environment, this sign here confirms it. So now we can install the libraries that we need. For example, in this episode, pip install NumPy. Then here we are installing the Python library just inside of our virtual environment and not in our computer. So now that we are all set up, let's move to the two examples that I have prepared for this episode. Okay, so once NumPy is installed, it doesn't mind that if here there's a warning, because as NumPy is not installed locally in your PC, it's not getting detected, but we are going to execute the examples. We will see that work because we are executing from the virtual environment. So let's start with first example. So we are going to perform some matrix calculus. So for example, let's start defining a first matrix called A, and this will be defined as NP. This is the way we call the NumPy library, and we define it as an array. It's the proper way to define a matrix. So let's start with random values here. Let's say that we have a matrix with 3 rows and 3 columns. I'm not doing this To define a matrix, we use this per row and then this comma to change. So let's say 5 here, -3 here, 2 here, for example, and then for example 3, -1, 6. All right, we are going to add this to close the general matrix. So we here have a matrix. For example, to see it better, we can add some intros here. Perfect. And then we also, to perform some calculations with this matrix, we also need, for example, a vector, call it B, and we are going to define it the same way. Vector could be, for example, is the same as a matrix with only 1 row. So what we are going to do is, for example, 2 and 3. So we have here matrix, and here a vector, both defined using NP array. Both are arrays of data, but in this case the difference is that a vector is only an array of 1 row. Here we have 3 rows. So let's start with some calculations. What we can do is, for example, some resolution. Okay, so here we have, for example, a system of equations, being this the system and this, for example, the results, being this the first equation, this the second one, and lastly this is the third one. So, for example, to solve this, we are going to use so solution is NP using linear algebra, the NumPy library. We're going to do solve, and here we are going to do this. Then we can print the solution. So, for example, to test this and this and show that works, model. So if we execute this example, what is going to happen is that we have a singular matrix. This means that this is not solvable because we defined random values here, so this is not going to work. So let me add normal values that I have prepared and solve the example properly. So what I've done here is change the values for ones that will work when we execute the script. So let's check it, and the solution is empty because I'm not printing a thing. So fuck. Do this to convert to string. Perfect. We have the solution of this equation system is this one. So to understand this example, let me explain with Paint. We are going to translate this matrix, to real equations. So what we are going to do is, for example, translate this. So for example, we have in the first row 10x minus 2y plus 3z. Each number is the coefficient of each variable. So we have 3 values, so we have 3 variables, and then this is equal to the first number of the b vector. Okay, we have one equation, 3 variables, so this is for now unsolvable. We need to add the second equation. Wow, too bad at this. Wow. Well, this is -1, so we can just skip the 1 and add here a -5. Now we have three bars and 2 equations, and this is still unsolvable. It's not. We cannot determine the solution of each variable, so we need also the last equation to have 3 variables and 3 equations to be able to solve this. So we are going to do this like and this is equal to the last value of the p vector as we defined in the example. So here we have these equations translated to NP NumPy arrays. We could solve this system of equations by hand, applying calculations and mathematical systems, but here with a single Python line we can have the solution. So the solution is this one. For x we have 0.48 and a bunch of decimals. For the y value we have -0.22, and for the z we have that the solution is 2.21. We could also perform some checks that this is correct, so we can, for example, with the solution perform the matrix with multiplication with solution, and this should provide the vector. So this is a law from matrix calculations. We can see here that the solution, well, we print the solution first and then the calculation. We could, for example, to see it better, do it this way, clear this, execute it, and we have here the solution once again, and we verify that the calculus is correct. Well, now we can move to another example. So to do that we are going to create a new Python file, example 2, and here we are going to do the same, import NumPy as np, and here we can do, for example, well, we are going to perform some calculus and print it using some graphs. To use graphs we are going to import matplotlib as this is done by plot as PLT. As we are working on virtual environment, we need to install this, so pip install matplotlib. This is the package that handles the plots in Python. Well, it's maybe the most common package. There's other libraries that can also deliver plots, but this is the most common and basic. So we are going to perform here some calculus and then show it using some graphs using this complementary library. So in this episode we are going to see 2-in-1 Python libraries, but focusing only on NumPy. That is the main objective of this episode. So for example, what we can do here is simulate the performance of reading from a sensor, read data from a sensor, and we could then print this data. We can print this data and we can perform some data treatment and print it also on the same graph. So for example, we can define a frequency. Let's say this will simulate the frequency that our system is reading, then a time, using NP linspace, starting from 0 to 1. Well, this is not time. We can set different name called values. We want values from 0 to 1, and for example 100 values. This generates a bunch of values, well, a defined number of values that is this third parameter. So we are going to have 100 of values between 0 and 1, and we are going to store it here in the values variable. So let's simulate the signal. For example, this signal could be 0.3 per. Let's simulate a sinusoidal signal. Sinusoidal signal is defined by p number. This is the way to call p number using the NumPy library. So in order to perform something like this, and only have 4 decimals, it's better to have the full number stored here and NumPy provides it. And we are going to, this is values. I set time here because we are going to use these values as the incremental of time that will the signal follow, because we are having a values from 0 to 1 incremental. So for example, this signal, let's see the signal first and do plot is the way that we named the matplotlib package. So let's say values and signal here, and we add a label. Example. Let's execute this. Oh, okay. We forgot that the sinus is provided also by NumPy. My bad. We execute this and then. Okay, my bad also. To show the plot, we have to show the plot using this line. Perfect. So here we have the plot with the sinus signal that we have generated. So this is we are not performing some calculus here, just showing how to create a signal. We forced these signal values using linspace, so this can be used with real sensor data, for example. And then to perform some calculus, we are going to add some noise to this signal, and then we are going to filter this signal and show all in a plot how the signal is being changed. So let's start adding noise. And this noise would be a random number, so for example NP random is used to add random noises, random values. Using the same of this. Oh, I added this frequency, and this should be here. So we could have it would be the same. All right, so we have random values here in noise. 10,000 random values that will be added to our signal. To do this, we are going to define a signal, a noisy signal, and we are going to simply perform this. Okay, so to view this signal, for example, we can do this. As you see, now this signal is very noisy. The previous one was a smooth line of the sinusoidal signal. So we can do now is clear this signal. So to filter this, we are going to use let's add here a window that is size 20. Window size will define the number of values that our filter is going to use. So what we are going to do is provide a vector, base it on one's value. So we are going to have a vector of 20 values of ones divided by, well, this. What do we have here? Here, first of all, we calculate using MP1s. MP1s, what it does is transform an array of one's value with the size of the variable that is put in here, and then what we are doing here is divide by the window size, because this is the filter that we want to apply. Okay, so here we have the filter called vector. We can call it filter, and then we have this noisy signal. To perform the filtering calculations, we need to do the convolution. That is the way to generate a third signal from two previous input signals, and this is the way to smooth these two signals all in one. So we are like reducing the noisy signal using this filter that is with values like this every time. So to do this, we are doing the np convol with the noisy signal, with the filter signal, and here we have to specify the mode of the calculation. This is mode same, and then if we want to see the filtered signal, we only need to do this. As we've seen, these have changed a lot of the previous ones, but to have a clearer view, we can add two functions on the same plot with values, noisy signal, label, example, let's say here noisy, here smooth. Then we add a legend, because here we have two signals. This is done with this command. So what we are doing here is plotting two signals in the same graph. We add legend here, and then we show the graph. Then we can move to execute this. Fantastic. Here we have a clear view of what we have done. The blue signal was the noisy signal shown in the legend here, and we see that we have reduced all the noise. We could also plot the original called signal values, signal with a label original, and here we could see the signal. The blue one is the original signal. Then we have the noisy signal in orange that is raised up because we added here the noise. And then from the noisy signal we have the smooth signal that reduces the noise of the noisy signal here. So well, these are two examples of how to use NumPy. First of all, we've seen some matrix and equation system calculations, and then here we've seen how to perform some data treatment, for example. We have seen how to smooth signals, how to plot also signals, and perform the convolution operation. That is quite interesting. So keep in touch to the next episode that we will be treating with a new Python library.